Good afternoon, my dear students. My name is Dr. KCH Apparao, working as an associate professor in Mechanical Engineering Department. Today, I would like to explain critical thinking questions mainly on dimensionless numbers. We know that dimensionless numbers because we know that convection process. Uh, so you know that convection process uh, to find the rate of heat transfer through convection. Uh, so there is a formula that is given by Newton's cooling law. We already discussed in previous class also. According to Newton's cooling law, Q is equal to HA into temperature difference, T naught minus T infinity. Okay, or Ts minus Tf fluid temperature. Okay, Ts minus solid temperature minus fluid temperature. Okay. So convection is completely associated with the movement of the bulk movement of the particles. You know that without movement of the particle, there is no convection process. It means heat transfer doesn't takes place by convection process without movement of the particles. Okay, so particle movements are bulk movement of the particles as is associated with the convection process. We already know this one. Okay, so but this movement of the particles from bottom to top or from one place to another place is two types. That is natural movement of the particles or movement of the particles by some external agent. Okay, so the movement of the particles occurs by naturally. It means by buoyancy effect. So that is nothing but a natural convection process. Here you can observe here. If you give the heat to bottom surface of the container, so automatically bottom surface will be heated. Then the heat is dissipated or heat is transferred from the bottom surface to nearest particles. When the particles of the water or any fluid heated, so the particles density will be decreases because density rho is indirectly proportional to temperature. Okay, so according to this formula, universal constant formula, rho is equal to P by RT. So here pressure and R is constant we can take, then rho is indirectly proportional to temperature. If the temperature increases, automatically density will be decreased. Then this less dense particles will move upward direction. Heavy density particles move into downward direction. So in this case, the particles moves from bottom to top by the effect of buoyancy. It means movement of the particles occurs here by naturally. So this process is nothing but natural convection process. Okay, the movement of the particles occurs by some external agent. So like this one. So this is nothing but a forced convection process. Now we'll see. But in convection process, to study the convection process, it is very critical because fluids have many properties: density, viscosity, kinematic viscosity, and velocity, and surface tension. Many parameters are there. Okay, so to study the effect of each parameter on conduction and convection, it is very critical thing. Okay, so for this one, we have to convert these parameters, these properties into some dimensionless numbers. We'll see what are those dimensional numbers. So before, convection is the complex heat transfer method. So because can be extracted by Newton's law. So by the help of the Newton's law, Newton's cooling law, you can find out the rate heat dissipation by or rate of heat transfer from solid to liquid. You know this one. It simply says that the rate of convection heat transfer expressed in units is proportional to difference between the initial temperature of the material and the final temperature of the material through professional constant H. So you know that Newton's cooling law. Okay, so we'll see here particularly the heat lost by convection is extremely complex process. The extremely complex process controlling variables, because the controlling variables are numerous, because the properties of the fluids are very high. It means many properties are there. Density of the fluids, viscosity of the fluid, kinematic viscosity of the fluids, and many properties are there. Surface tension of the fluids, so, okay, velocity of the fluids. Okay, so many parameters are there. So it is difficult to study the effect of each variable or each characteristic or each property. So in this process, so effect of each variable in this process is very critical. So it is difficult to study the effect of each variable in this process, but it is possible to investigate experimentally and express scientifically the results for any one geometrical configuration using the dimensional analysis. By the effect of by using the dimensional analysis, we can convert these properties, these variables, into some dimensionless numbers. Okay, so we'll see what are those dimensionless numbers. The major advantage of the dimensionless analysis is to reduce the number of variables in a problem with the help of the dimensionless analysis. We can combine the variables of the problem into dimensionless groups. Okay, so these dimensionless groups are dimensionless numbers. So the main dimensionless numbers are Reynolds number, Prandtl number, or Grosov number, or Nusselt number. So these four are very important numbers. So we'll discuss what is the importance of those dimensionless numbers here. Okay, so first of all, we will see here just these are the questions which are given in our question bank. We will discuss this one. So what is the physical significance of the Nusselt number? So this Nusselt number is nothing but a dimensionless number. How is it defined, and what is the physical significance of Nusselt number? We will discuss in this class. One more question is what is the physical significance of Reynolds number? So this Reynolds number also dimensionless number. Okay, how is it defined for external flow over a plate of length? Okay, so based upon the Reynolds number, we can identify the flow, so which is laminar or turbulent. Okay, how does the Rayleigh number, okay, differ from the Grosov number? So what is Rayleigh number? What is Grosov number? What is the importance of this Grosov number? Also, we'll see here. What is Rayleigh number? Discuss the nature of flow with respect to it. So many questions are given in question bank which are related to this dimensional numbers. We'll see what are the different dimensional numbers. What is the significance of those dimensional numbers? Okay, the first one is the Reynolds number. Is very important. So we'll see what is Reynolds number, what are the different properties of the fluids are included in Reynolds number. So it is the ratio of inertia force to viscous force. So inertia force by viscous force, that is nothing but a Reynolds number. Okay, in the velocity boundary layer, we will see what is velocity boundary layer. So it is used in the mainly forced convection. This Reynolds number is used to explain the forced convection process, not natural convection process, because it includes the velocity. Here we will see the formula. Reynolds number is equal to inertia force by viscous force. Okay, inertia force is equal to rho ux into LC characteristic length by mu, and then mu by rho. Mu by rho is equal to nu. This is the kinematic viscosity. So ux or ulc by mu. So this is the formula for the Reynolds number. Okay, rho ud by mu, rho ulc by mu. So this is the formula, or mu by rho is nothing but nu. So this is the formula. LC is the characteristic length of rectangulars. If it is the pipe is geometrical construction is circular, then rho ud. So diameter of that pipe. So the finally Reynolds formula is equal to rho ud by mu or ul by nu. Okay. So LC, this is the characteristic length of flow geometry. That geometry either rectangular shape or circular shape or any type. Okay. So is equal to x. So this is the x distance from the leading edge in the flow direction of the flow. So sometimes LC is equal to t because the geometry is the cylindrical type or spherical type. You can take. Okay. If you can, LC is equal to x if it is in rectangular form. So u or u alpha, that is the free stream velocity. Suppose this is the surface, flow is like this one, fluid flow is like this one. The velocity of this one is equal to u alpha. Okay. So in the forced convection, we will see velocity of the fluids. So u alpha is equal to free stream velocity, rho is equal to fluid density. Okay. Mu is the dynamic viscosity of the fluid. Okay. Mu is nothing but kinematic viscosity of the fluid. Mu is equal to mu by dynamic viscosity by density. You know that formula. Okay. The finally Reynolds number is the dimensionless number. So if you apply the dimensions units, you will get to a unitless number. The formula is equal to, you know, that ul by nu. Okay. So this is the unitless number. This is the dimensionless number. So this mainly used to study the or to understand the forced convection process. Okay. And mainly it is used to identify the flow based upon the value of the Reynolds number. You can understand that flow is either laminar or turbulent. Okay. So okay, we'll see. That is the importance of main importance of the Reynolds number. Now we'll see critical Reynolds number also, the value. Based upon this critical Reynolds number, you can specify which type of flow. So to identify the flow either laminar or turbulent, it is depend upon the critical Reynolds number. Okay. So what is critical Reynolds number? Critical Reynolds number is the value of Reynolds number where boundary layer changes from laminar to turbulent. Okay. So from that point, from that Reynolds number, the flow will change from laminar to turbulence. Okay. It is denoted by RE, Reynolds number, critical. So critical Reynolds number. For the flow over a flat plate, the transition from laminar to turbulent boundary layer occurs roughly, and the critical Reynolds number is, the value is equal to, so this one. Okay. If the RE is greater than 5 into 10 to the power of 5. Okay. 5 into 10 to the power of 5. So that shows the, if it is greater than, that is the turbulent flow. If it is less than, that is the laminar flow. Okay. So this is the critical Reynolds number point. So critical Reynolds number value. So above the critical Reynolds number, so that shows the turbulent flow. Below this means that shows the laminar flow. Okay. So in fluid flow through pipes, it is the fluid flows on a rectangular plate. Here, if the fluid is flows through some circular pipes, here critical Reynolds number value is equal to 2300 value. Okay. So if the critical Rayleigh number value is greater than 2300, then that shows the turbulent flow. If it is less than, that shows the laminar flow. So this is the significance of Reynolds number to understand the flow and to understand the uh, forced convection process. Okay. So now we'll see Prandtl number. What is the importance of the Prandtl number? So Prandtl number is defined as the ratio of momentum diffusivity to thermal diffusivity. Momentum diffusivity to thermal diffusivity. Okay. So the Prandtl number, it is represented by PR. So that is called to momentum diffusivity mu by thermal diffusivity alpha. Okay. So you know that alpha in previous classes also we see that one. So alpha is equal to K by rho Cp. So this is the value. Okay. This is the mu is the kinematic viscosity. We can convert into dynamic viscosity. So kinematic viscosity is equal to dynamic viscosity by density. Okay. If you substitute the values, so nu place nu by rho into alpha place, so that is the K by rho Cp. Okay. This row will be cancelled. Then the final formula is equal to mu Cp by K. Mu Cp by K. Mu is the dynamic viscosity, Cp is the specific heat, K is the thermal conductivity. So these are the properties of the fluid, you know that. So the combination of this is nothing but Prandtl number. This is the dimensionless number. By using this number, you can understand the functioning of temperatures. Okay. So it provides a measure of relative effectiveness of momentum and the energy transfer in the velocity and thermal boundary layer. So understanding of energy transfer in the velocity and thermal boundary layers. Okay. So in the thermal boundary layers, in velocity boundary layers. So energy transfer you can understand here. You can see, we'll see. So next one is the Grosov number. Okay. So this is the third one number, Grosov number. This is also dimensionless number. Mainly this is used to understand the natural convection process. So we'll see what is Grosov number. It is defined as the buoyancy forces to viscous forces. Buoyancy means the effect of buoyancy that shows the natural convection process. So buoyancy forces to viscous forces acting in the fluid layer. Okay. So it is in free convection or natural convection. So its role is same as the Reynolds number in the forced convection. It means so the forced convection Reynolds number is used to study the forced convection in a similar manner. Grosov number is used to study the natural convection. Okay, it is denoted by GR. Okay, Grosov number. So this is the formula. You know this one. Grosov number is equal to buoyancy force by viscous force. So this is the final formula. G into beta. So 1 by T mean. Beta is nothing but okay into delta T temperature difference, characteristic length by mu square, kinematic viscosity square. Okay. So acceleration due to gravity, B is the coefficient of volumetric expansion. So this is the value. The T mean should be kelvins. You have to remember this one. So TF is the mean temperature difference. You know that TF is the Ts plus T fluid by 2 and nu is the kinematic viscosity. By using these parameters, you can find out the Grosov number. By using the Grosov number, you can understand the process of convection process, natural convection process. Okay, now we'll see. So this is the characteristic length. The importance of characteristic length also is very important point to understand the flow. Okay, LC is the characteristic length of the body. For rectangular bodies, LC is nothing but L. You can take. For the circular bodies, LC is nothing but D. Okay. So for different two objects means you can take surface area by perimeter remaining also. So it means so AS by P. By using this formula, you can find out the LC. Okay. So for other geometries, for rectangular bodies, you can take L. For circular bodies, you can take LC is equal to D. For other geometrical constructions or other geometrical bodies, so you can take this formula to find out the LC. Okay. So it is mainly for the to understand the free convection process. Okay. Here also similar to Reynolds number, you can find out you can identify the flow of the fluid, either it is turbulent or laminar. So this shows the Grashof number. So critical Grashof number GRCR is equal to 10 to the power of 9. Less than 10 to the power of 9, that shows the laminar flow. Greater than 10 to the power of 9, that shows the turbulent flow. Okay. So in natural convection, to identify the flow of the fluid, we will use Grashof number. In the forced convection, to identify the flow of the fluid, either laminar or turbulent is, so we used the Reynolds number. So the functioning of Grashof number is, you will see in natural convection process. Functioning of the Reynolds number we will see in the forced convection process. Okay. Now we'll see last one is the Nusselt number. It is very important. So it is defined as the ratio of convection heat flux to conduction heat flux. Convection heat flux means H related. Conduction heat flux means K related. Okay. The formula is equal to, you can take like this one. So this is NU, Nusselt number. Okay. So Nusselt number is represented by NU. Convection heat flux by conduction heat flux. Okay. Convection heat flux by conduction heat flux. Convection heat flux occurs by Newton's cooling law, HA into delta T. Conduction heat flux, Ka delta T by LC. Okay. Area, same area, you can cancel that one. Okay. Then area, here also area will be cancelled. So then H delta T by K into thermal conductivity into delta T by LC. Okay. So here delta T cancel. LC comes into top portion. H LC by K. So this is the formula. H LC by K. So LC is the characteristic length. So same formulas. If it is rectangular, you can take direct L. If it is circular, you can take, that is the diameter. If for the other geometries, you can take perimeter by ES. ES by perimeter, sorry. ES by perimeter. So you can use this formula to find out the LC value, characteristic length value. Okay. So here we will see delta T is the temperature difference. You know this one. Surface temperature minus fluid temperature. H is the heat transfer coefficient. You know that one. Watt per meter square Kelvin. LC is the characteristic length of the fluid flow. LC, and K is the thermal conductivity of the material. Okay. So these are the parameters which are included in Nusselt number. Okay. So Nusselt number also, this is the dimensionless number. It is used to identify the study the convection process or conduction process. In both processes, we will use the Nusselt number to find out the H value, rate of heat transfer value. Okay.
Like, share and subscribe. Hit the bell icon for more updates.